In 1998, Russia launched the first module of the International Space Station, ISS, and on November 2, 2000, a Soyuz spacecraft carrying 2 Russian cosmonauts and 1 American astronaut arrived with the first crew, marking the space station's continuous occupancy since then. In its 24 years of service, the ISS has had over 270 people flown to the station from 22 countries. By most metrics, the ISS has been a success, but like all beneficial things, it is coming to an end. The space station is showing its age, and with that age comes increased risks to the crew. The most concerning issues are the small, yet persistent leaks, one of which has persisted since 2019 and remains unrepaired. The leaks indicate the aging space station's vulnerability to the harshness of space, including cosmic radiation, prompting international partners such as the United States, Russia, Canada, the European Space Administration, ESA, and the Japan Aerospace Exploration Agency, JAXA, to discuss the space station's retirement in 2030. The question is, what will replace the ISS? The international partnership responsible for managing the International Space Station, ISS, is planning to deorbit it. They have contracted SpaceX to develop a spacecraft that will manage the station's safe deorbit, culminating in a burn-up and crash landing in a sparsely populated ocean location sometime around 2030. A wrinkle in this plan is that Roscosmos, Russia's governmental space agency, has committed to the ISS only until 2028. Only trained Russian crews can manage the Russian section of the ISS, and Russia maintains the station's attitude control through its Soyuz spacecraft. Boeing Starliner was to give the U.S. that capability, but its fate is up in the air, and most likely, it will never fill that role now that SpaceX is contracted to manage the controlled re-entry burn of ISS. This implies that the International Space Station, ISS, regardless of the wishes of its non-Russian international partners, might not be able to maintain its operations without Russia. ISS partners are exploring options for this eventuality and have not yet set a plan. However, an intriguing discussion suggests that the current parts of the ISS, under the management of new partners, could potentially replace it. An unusual scenario, resulting from the Ukraine war, involves Russia disconnecting and detaching the Russian modules and operating them as its own Russian-only space station. This seems impractical, but it would give the cash-strapped Russians an option to maintain their presence in space. The fate of the remaining ISS would be unknown if this were to happen. The other option is that a private company or consortium buy parts, or all of the ISS, from the international partners and continue to run the aging station. This option offers the benefit of using the ISS components as the foundation for a new space station, which could eventually replace the original components. The ISS has already tested this concept. NASA awarded Axiom Space a contract in 2020, enabling it to attach 4 modules to the ISS starting as early as 2026, and add additional modules at a rate of 1 per year. SpaceX plans to launch a total of 7 modules for Axiom, enabling it to separate from the original ISS and operate independently with its own power and airlock. Space Crew Dragon and Cargo Dragon will be compatible with this Axiom design. Axiom has not finalized its plans, but the timeline suggests that the 2030 retirement of ISS is not a set date. ISS partners except Russia would not have access to one option that is already in space. The Chinese Tiangong space station, in orbit since 2021, is currently undergoing expansion. After the retirement of the International Space Station, the Chinese Communist Party aims to replace international space cooperation with their own station. This seems excessively ambitious, considering that the Chinese program has not received significant international cooperation, and the Qinggong entirely relies on Chinese technology, with no signs of this changing in the near future. Though the Ukraine war has drawn Russia and China together, it would not be unrealistic that there could be Russian and Chinese cooperation in space. NASA is partially funding a commercial station proposal by Blue Origin and Sierra Space under the NASA Space Act Agreement in 2021, named Orbital Reef. Blue Origin and Sierra Space are touting this option as a business park in space, and not as a space tourism destination, separating it somewhat from the ISS. There are no anticipated launch dates for this space station, as it depends on 2 unproven technologies to reach space. Orbital Reef's construction depends on the Blue Origin New Glenn heavy lift rocket, which has yet to fly and has a launch date of no earlier than November 2024. The New Glenn was rolled out to LC-36 at Cape Canaveral in late October for a first-stage test fire, which has not yet occurred and requires success before a launch date is set. The Sierra Space Dream Chaser, which will transport the crew to the orbital reef, has yet to undergo a crew-rated vehicle test, and an unmanned demo launch is not scheduled until May 2025. A timeline for Orbital Reef will not come into focus until New Glenn and Dream Chaser are operational. The NASA Space Act Agreement supports Starlab, another American entry, which is a partnership between NanoRacks, Voyager Space, and Lockheed Martin. Starlab will use a novel inflatable design for its module, which has already been tested on the ISS, though it was never a manned part of the ISS. Similar to the Orbital Reef, Starlab relies on unproven technology, opting for the SpaceX Starship and Super Heavy booster to launch both the Habitat module and Space Park simultaneously, thereby significantly reducing the project's cost. Currently in the test phase, Starship has completed 5 test flights, reaching orbital velocity but not orbit due to flight plan limitations, and not hardware limitations, with a 6th test flight scheduled for no earlier than November 2024. The Northrop Grumman Cygnus spacecraft can deliver supplies, while Starships will shuttle crews to the space station. Expected to launch into space at least in 2028, Starlab relies on SpaceX to human-rate the Starship. Northrop Grumman is a NASA Space Act Agreement company and has submitted a design for a 3-module space station based around its Cygnus spacecraft that delivers cargo to the ISS. The advantage of Cygnus is that it is based on proven technology, so the development costs are generally lower. Cygnus has also leveraged the proven SpaceX Falcon 9 rocket, and both Cygnus and Dragon, both crew and cargo versions, utilize the same ISS docking designs, eliminating the need for the development of new technologies. Northrop Grumman plans to launch its space station no earlier than 2028, aiming to make it available before the decommissioning of the ISS. The new space station is expected to be used for space tourism, human and microgravity science. NASA has not backed Vast Space's suggested entry, but private finance is creating a lower-cost entry. But the Vast Space Station could launch first using the SpaceX Falcon 9 and Crew Dragon and be ready by late 2025. NASA will most likely not use it, but would serve space tourism and privately funded microgravity experiments instead. The SpaceX Starship can lift Europe's Airbus Loop design, which currently lacks a sponsor, in a single launch. India is also working on a space station concept called ISRO Space Station, which will not be available until the mid-2030s. As India still has a number of milestones to achieve in its manned flight program, with its first manned flight not expected until 2025. If NASA decides not to fly the Boeing Starliner again, the exploration of numerous options suggests a potential future for the spacecraft. The Starliner will have compatibility with the Axiom Space Station, Starlab, Northrop Grumman Space Station, Vast Space Station, and most likely the Orbital Reef if it decides to venture into the commercial low Earth orbit space station and space tourism market. If Boeing can get the Starliner thruster issues fixed, it could take over the ISS attitude control functions from the Russian Soyuz as well. The overall point is that there will be plenty of options available before the ISS decommissions in 2030, but potential Russian actions to stop support by 2028 could pose a challenge that NASA has not yet resolved. NASA and commercial partners should prioritize maintaining ISS operations until 2030 to allow the private sector to implement their various plans, thereby ensuring full funding for the NASA Space Act Agreement. Decommissioning and deorbiting the ISS before the private venture timelines could lead to appropriation issues and potentially impact projects such as Axiom Space, which rely on the ISS as a starting point.